So in this construction, we want to see how we can construct the perpendicular bisector of a line segment using only a compass and straight edge. So here we have our line segment, and we want to find the perpendicular bisector of this segment. So the first thing we are going to do is to label each end of our line segment. So we have labeled one end the point A and the other end the point B. What we wish to do now is to draw two circles, one centered around the point A and one centered around the point B. We have two conditions on these circles. The first condition is that whatever radius of a circle we draw centered on the point A, the circle we draw centered on the point B must have the same radius. So whatever setting we use on our compass for one point, we use the same setting on our compass for the other point. The second condition is that the radius of these circles must be greater than half of the distance between these 2 points. The reason we have this condition is that we need for these two circles to intersect. So we'll draw the first circle centered around the point A. And now we'll draw another circle centered on the point B, which has the same radius as the circle we just drew around the point A. Okay, so we've drawn those two circles, and what we are going to do now is mark the points of intersection of these two circles. So you can see we have marked points C and D, and what we are going to do now is draw a line through these 2 points, and this line will be the bisection of our line segment AB. Okay, so I'm just going to mark this point of intersection. We mark that point O, and that is our construction complete. So what we want to do now is take a look at why this is a valid construction. So the first thing we are going to do is we are going to draw 4 lines, one from A to C, one from B to C, one from A to D, and one from B to D. Okay, so we've drawn those 4 lines. So since we have two circles of the same radius, we can say that the length of the line segment AC is equal to the length of the line segment BC. And so this means our triangle ACB is an isosceles triangle, which tells us that the angle CAB, which is this angle here, is the same size as the angle CBA, which is this angle here. By the same reasoning, the line segment AD is the same length as the line segment BD. So we have another isosceles triangle, the triangle ADB, and so the angle DAB, which is this angle here, is the same size as the angle DBA. Now, what we have, if we take the triangle CAD and the triangle CBD, these two triangles are congruent triangles, and they're congruent by side, angle, side. Because these two triangles are congruent triangles, we have that the angle ACO or ACD is equal to the angle BCD. So we have this angle here is equal to this angle here. Now if we take a look at the triangle ACO and the triangle BCO, These two triangles are congruent triangles, and they're congruent by angle, side, angle. And since they are congruent triangles, then the length of the line segment AO must be equal to the length of the line segment OB, and the angle AOC must be equal to the angle BOC. Since these two line segments are the same length, and these two angles being the same must be 90 degrees, we have that the line COD is the perpendicular bisector of the line segment AB.